Assalamualaikum warahmatullahi wabarakatuh, Dr. Rin. So we are from group 2. We'll be present about the properties of relation and relation closure, which is transitive, reflexive, and also symmetric. So for this project, we are given 4 topics and we must choose one of them as our mini project. So for our project, this system was designed in order to address issues raised by the preceding question. A relation is any link or connection that exists between items of one set, known as the domain or set of the inputs, and elements of another set, known as the range or set of outputs. This relation that classifies into 3 types, which is reflexive, transitive, and also symmetric.
Normally, the user must manually type and calculate each step in order to get the solution. However, it takes so much time in order to understand the topic. So by utilizing our system, users are able to double-check their work and prevent trivial errors such as misplacing relation when attempting to get the solution. So, the system that we design will be able to identify when the given relation is reflexive, symmetric, or transitive, and even if it is an equivalence relation. Furthermore, the system can also construct the transitive closure, symmetric closure, and reflexive closure, and the consequences, users are able to save a lot more time and avoid careless error. Users will be asked to give data in the form of numbers, and it will establish the relation based on the criteria that have been defined.
So I will continue on the demonstration of the properties of relation application. So we use C++ in order to generate the properties of relation. In this line of codes, we use the declaration of variable. And this is the welcome string codes. And this is the codes where the user need to prompt the input of the number of set. And we use for loop in the looping process for user to prompt the elements based on the number of sets entered. And it will display the set entered. And then this is the codes whether to check the sets are reflexive, symmetric, or transitive. And this is the lines of codes to check whether it is reflexive. And this is to check whether it is symmetric. And last, the line of codes to check whether it is transitive. Next, I will run this code. So this is the welcome screen for our properties of relation generator, which will identify the transitive, reflexive, and symmetric, as well as the transitive, reflexive, and symmetric closure. So let's say the user enter the number of set, which is 4, and enter the element of A1 is 2 and 4, and the second ordered pair they enter is A, the third ordered pair they enter is 6, 5, and the last ordered pair is 4, 7. And it will show the output of the result. So this is the set of element, which is 2, 4, 8, 8, 6, 5, and 4, 7. And the reflexive is 8, 8, which is, we know that the reflexive is A, A in the ordered pair, which is equal to each other. And the symmetry in this set of element is 8, 8 also, because it does not have AB equals to BA ordered pair. And there are no transitive in this set. Next, I will pass to Nadira to continue on the reflexive, symmetric, and transitive closure.
I will explain about the derivative of relation. So this one is part of coding to check for all elements exist in the universe. This one. And this part is for reflexive closure. We use for loops for this one to check the elements to be put inside of closure. Next is symmetric closure, used for loop also. This part is B, I, and AI is for symmetric closure outputs and put for transitive closure, which is trans AI and trans BA. And this output for transitive closure. So next we go for the demonstration. This is the outputs. We use the same number of sets. So this is the set of elements. So this one is reflexive closure. For reflexive closure, we just simply add another element to fulfill the condition of reflexive, which is we already have 8, but we don't have to do 6, 5, 5, 4, 4, 7, 7. So we add on this set of elements. So for symmetric closure, we add pairs of elements, which is 4, 2, 5, 6, 7, 4, because the condition for symmetric is to switch the number for elements A and B, which is we have 4, 2, 5, 6, 7, 4. And next we go for transitive closure. Simply add another relation to make it transitive. So we have relation 4, 2, 4, add 6, 5, 4, 7, but we don't have 2, 7. So that's why we put it here 2, 7.
Moving on to the project limitations. First, it's not user-friendly because it does not have a GUI. A GUI is a graphical user interface where it is a system of interactive visual components for computer software. A GUI operating system are easier to learn and use because commands do not need to be memorized. Besides that, it does not have a clear explanation for each properties, so the user may not understand and confuse and would need a further explanation. And next is simplicity, where a Python language can be more complex, while a C++ language are limited.
In conclusion, we have seen that each input entered by the user will produce a different relation type output according to its own closure, whether it is transitive, symmetric, or reflexive. Therefore, the user problem have been solved by this system.